Hello everyone, welcome to Digital Communication Tutorials. In this video, I am going to take up the derivation on the raised cosine spectrum. Let me read out the problem at hand first. For a raised cosine spectrum with a roll-off factor of unity, show that the time response is given by P of t equal to sinc 4 b naught t divided by 1 minus 16 b naught square t square. Right, let us start with the solution part. I would like to start the solution with the equation for the raised cosine spectrum, which is given by right. This is the equation for the raised cosine spectrum. As you can see, it has a flat portion for values of frequencies less than f1, and for frequencies from f1 to 2b naught minus f1 there is a rolling factor, and for frequencies greater than 2b naught minus f1 it is equal to 0. Let me now sketch this spectrum and show you how this would appear. As per the question here, we are asked to find the time response for the raised cosine spectrum. Please note, we are told the roll-off factor is equal to unity. So, let us write an equation for the roll-off factor and relate it with the other terms in the equation for P of f. It is given by alpha equal to 1 minus f1 divided by b naught. But since it is given as alpha is equal to 1, we will now substitute it as it is 1 equal to 1 minus f1 divided by b naught. Therefore, f1 is equal to 0. Now, we go back to the equation for P of f, which let me call is equation 1, and substitute in this part the value of f1 as 0. So, let me just now do that. Therefore, P of f then would become 1 divided by 4 b naught into 1 plus cos pi into magnitude of f divided by 2 b naught. This is, let us say, equation 2. Let us now try to find the time domain response, which can be obtained by simply applying the inverse Fourier transform on equation 2. Let me start with that part. That is, P of t is given by integral minus infinity to plus infinity P of f into exponential of plus j 2 pi f t df. Let me now substitute equation 2 into the current equation, which I will call equation 3. Here it should be noted that P of f is real and even. Therefore, the exponential of j 2 pi f t can be replaced by cos 2 pi f t. Let me write that part here. Therefore, equation 3 reduces to let me now substitute P of f, which is as per the equation 2. However, when you come back to the original equation, you will note that this is defined over f1 to 2b naught minus f1. So, the overall bandwidth of this is supposed to be minus 2b naught to plus 2b naught. So, when I come back to the equation, I will start by changing the integral limits and replacing the value of P of f by the equation 2 RHS here. So, this is integral minus 2b naught to plus 2b naught multiplied by 1 divided by 4b naught into 1 plus cos pi f divided by 2b naught into cos of 2 pi f t df. I'll rearrange this and I'll multiply cos 2 pi f t df with the contents of the bracket here. So, this is equal to 1 divided by 4 b naught into, we have integral minus 2 b naught to plus 2 b naught. This can be written as 2 into integral 0 to 2 b naught, followed by, let us multiply 1 multiplied by cos 2 pi f t. This would be cos of 2 pi f t into df plus cos of pi f by 2 b naught multiplied by cos 2 pi f t. I will write cos 2 pi f t first. So, it would be, if you look at this part, this is in the form of cos A cos B, and cos A cos B is equal to cos of A plus B plus cos of A minus B whole divided by 2. So, let me write that equation. I am going to use this equation in this part here. Therefore, P of t is equal to, right. Let us now integrate. So, this is equal to 1 divided by 2 b naught into integration of cos 2 pi f t df is equal to sin 2 pi f t divided by 2 pi t. Then we have a plus 1 by 2, integration of cos 2 pi f t plus pi f by 2 b naught is equal to sin of 2 pi f t plus pi f by 2 b naught divided by the coefficients of s. So, this would be equal to, then plus the same applies for cos 2 pi f t minus pi f by 2 b naught. So, therefore, it would be equal to, this is over the interval 0 to 2 b naught. Let us now apply the limits. Wherever there is an f, you substitute it by 2 b naught. So, this would become, let us now simplify this. This is equal to, now here if you look at this part here, we have sin some value plus pi, and then here we have sin some value minus pi. So, let us now use those values. So, I will write, we know that sin of theta plus pi is equal to minus of sin theta, and sin of theta minus pi is equals to sin of minus theta. Let us now use these trigonometric functions and reduce the equation for P of t. So, it would become plus 1 by 2 into, we have sin theta plus pi which is minus sin theta. So, it would become minus sin of 4 pi b naught t divided by, the denominator is retained as it is, then 1 by 2 sin of theta minus pi is sin of minus theta. So, it would be sin minus 4 pi b naught t divided by, denominator once again retained as it is. Continuing, I will take now sin 4 pi b naught t as a constant. Therefore, what remains inside the bracket is 1 divided by 2 pi t. The previous version should also be t, please make that correction. Then we have a minus symbol here followed by 1 by 2. Then we have 1 divided by 2 pi t plus pi divided by 2 b naught. Then we have sin of minus 4 pi b naught t, but what we have taken common is sin plus 4 pi b naught t. We know that sin of minus theta is equals to minus of sin theta. So, therefore, this also reduces to minus 1 by 2 followed by 1 divided by 2 pi t minus pi divided by 2 b naught. Let me now further simplify this. So, this would be 1 divided by 2 pi t minus of, I'll simplify this part and I'll take the 2 b naught to the numerator. So, it would become 1 by 2 into 2 b naught divided by 4 pi b naught t plus pi minus 1 by 2 into 2 b naught divided by 4 pi b naught t minus pi. 2 and 2 here gets cancelled, again the same happens in the next terminal. So, I will now take the pi in the denominator of the last two terms common. So, this reduces to now I am going to interchange these two variables. So, the minus here will become plus. So, this is equal to I am going to now take 1 divided by 2 pi t common. Let us now simplify this part. However, in the previous one there is a pi here gets cancelled. The same happens in the second term as well. Therefore, when I perform cross multiplication, I would obtain the denominator as 1 minus 16 b naught square t square. Now, we have to multiply the 1 here with the same, which is the denominator. Therefore, we will get 1 minus 16 b naught square t square minus of, we have left 2 b naught t here multiplied with this term. So, it is 1 minus 4 b naught t plus we have 2 b naught t multiplied by this term here 1 plus 4 b naught t. So, this is equal to 1 minus 16 b naught square t square minus of 2 b naught t plus 8 b naught square t square plus 2 b naught t plus 8 b naught square t square whole divided by 1 minus 16 b naught square t square. So, in the numerator you see minus 2 b naught plus 2 b naught. Then you see we have minus 16 b naught square t square and we have 2 plus 8 b naught square t square, they also get cancelled. So, what remains in the numerator is just 1. Coming to this term, you see this is in the form of sin pi into 4 b naught t divided by pi into 4 b naught t, and what remains here is 1 divided by 1 minus 16 b naught square t square. We know that sin of pi into x divided by pi into x is equals to sinc of x. So, this reduces to sinc 4 b naught t whole divided by 1 minus 16 b naught square t square. This is p of t, and if you go back to the numerical, you will find that this is what we have been asked to prove. So, we have now proven that for a raised cosine spectrum with a roll-off factor of unity, the time response is sinc 4 b naught t divided by 1 minus 16 b naught square t square. Right, that is about the derivation. If you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.